let's do problem number, oops, I forgot to put the problem number on there, number 60?
Yeah.
We're going to do problem number 60 on the E&M multiple choice test from 1988. And so here it is. It says, in the circuit shown above, the capacitor is initially uncharged. At time t equals 0, switch S is closed. The natural logarithmic base is E. Which of the following is true at time t equals RC? Now, the current, now they're asking about the current is this, or the current is E over R. The voltage across the capacitor is E. The voltage across the capacitor is this. So we can look at it in terms of voltage or current. Let's look at current first. Now remember, when I was reviewing this stuff, I said, look, we can construct the equation by just letting it make common sense. Here, obviously, when you close this switch, if it's just an RC circuit and we're neglecting inductance, if it's an RC circuit, you're pretending that the inductance of the circuit is 0. That means that the current will instantaneously go to its maximum value and go to 0 like this, right? Because, look, you close this switch, there is no voltage drop across the capacitor. There is no charge on the capacitor yet. So all of the voltage drop has to be across the resistor, which means we have maximum current across the resistor. Maximum current, which is E over R. And then but as the resistor fills up, it gains voltage, which means there's less, it gains a voltage drop, which means there's less voltage for the resistor, which means there's less current, until all of the voltage drop is across the capacitor, which means that there is no more current. So you can very quickly, though, if you remember that e to the negative t over RC. Now, we want this to start at its maximum. So at t equals 0, we want, this is current as a function of time. At t equals 0, we want this to be 1 because we want the current to be E over R. Okay. So, this is the equation that describes current. And so do you see how I constructed that, right? I mean, you have, with these exponential, with RC circuits, and you're dealing with exponential functions, you have a choice. Usually it's either 1 minus e to the negative t over RC, or it's e to the negative t over RC, times whatever it is, voltage, current, charge, whatever it is you're dealing with. Well, in this case, we want this. This is what the graph looks like. So it says, what is true when t is equal to RC? Well, I is equal to E over R times e to the negative RC over RC. Well, what is negative RC over RC? That's negative 1, right? Times e to the negative 1, and that is, in fact, E over R times 1 over E. And that's answer A. So, big picture-wise, what do you need to know? For a charging capacitor, for an RC circuit, you need to be able to just graph current as a function of time and know how to describe that function. Now by the way, we can easily construct charge as a function of time. Let's do that. Charge on the capacitor is a function of time. That's not what was asked for in this problem, but we can do it anyway. Look, at t equals 0, when you first close that switch, there is no charge on the capacitor. But as we go, it's going to fill up until it reaches its maximum. And what will that maximum charge be? Well, the maximum charge will be, what is capacitance? Capacitance is equal to the charge over the voltage. And in this problem, so you know that Q equals, am I still, no, I'm off screen, sorry. Let me move all the way over here. The capacitance equals the charge over delta V. So the charge will be equal to the capacitance times delta V. Now in this case, if you look at the problem, the voltage is E, and so the maximum charge will happen when you have C times E. So on my graph, this will be C times E. Now, how would I construct this as a function of time? Well, it's e to the negative t over RC. You just have to, like, if you have a discharging capacitor, you just have to remember that. And now I want it, at t equals 0, I want it to start at here. Well, when t is equal to 0, when t is equal to 0, 1 e to the 0 power is 1. So you know that if you want it to be 0, you have to go 1 minus that. And then we have the maximum charge, CE, over here. And this is equal to the charge as a function of time for this circuit. Now, if you take the derivative of this, the time derivative of this, you'll get this. Right? But this was easy to figure out anyway. So, when you have, big picture wise, when you have an RC circuit, just go e to the negative t over RC. Memorize that, and then you can kind of construct everything else you need by using, common sense. Thinking about, is it a charging capacitor? Is it a discharging capacitor? What's going on? Okay, I think we've beaten this problem to death. That is all.